Hello, welcome to our TED Talk class. Today we will speak about blockchain. And I know that it's rocket science nowadays. Many people are interested in blockchain, but not especially in blockchain, but about how to get rich playing with cryptocurrency, right? But when I thought about that, I think that cryptocurrency itself is pretty complicated topic. We cannot start it like immediately. So I think we will do it in two classes. Today, my plan is to talk about blockchain idea, to talk about hashing functions and a little bit cryptography. And then for the next class, we will be ready to start exactly about getting rich with cryptocurrency, how it works, what is money, what is crypto money, and all these things. Okay, so we have a TED Talk. Which I forgot the name, something simplified blockchain or something like this. And who want to be a summarizer? It's pretty simple talk, I think. So just a few ideas, maybe. Okay, please be muted. We hear all your noise.
Okay.
Gerard, maybe you want to be summarizer?
The blockchain. Okay, I hear a lot of noise, background noise.
Yeah.
You fix the problem, okay. So it's a new paradigm of cryptography of information. So people can access information in a secure way. And the good thing of that is cannot be tampered, is information. Because there is an algorithm, how do you call logarithm? Okay. Algorithm that tells us when someone tampers with the information. And the speaker said that this blockchain paradigm is a new breakthrough, something very important, but it doesn't work extensively yet. So the speaker expects that will be the new paradigm, but we'll see.
Mm-hmm.
I have my doubts about blockchain because when we read something about quantum computers and very powerful computers, I have doubts whether this cryptography can be hacked.
Yeah, but from my opinion, quantum computer it's not really related topic to that. It's about something different. But we can discuss it. So as I got it, first of all, it's not a brilliant TED talk in my opinion. It's just how to say it. It's just an attempt to explain something. Yeah, and it's attempt to explain the main idea without any any details. Just think what kind of problem do we solve? What kind of problem we are trying to solve? And speaker provided a few examples of previous problems, which are knowledge gap, power gap, distance gap, and now the problem is trust gap. So we can speak a little bit about that. What is knowledge gap? What is power gap? How we understand that, if you understand. Vasant, can you help us with that? Probably not. Diana, do you understand what is knowledge gap or power gap or distance gap? What is that?
Well, distance gap is pretty simple. So I cannot reach Teacher Lee, I can reach him only via our, technology, but not like, in our, how to say that, Teacher Lee, like physically. Okay, you want to? So cannot reach him because of this distance gap. What? Hello. She forgot to say hello. Yeah.
Okay. Hello.
Are you happy?
Yes. Stay calmer.
Okay. Don't talk, please. So as for knowledge gap, so well, a primitive example. So just let's say that you are trying to explain this concept to a 5-year-old. Okay, so maybe not only the 5-year-old, like the concept of the brain chain. What are we talking? Blockchain, brain chain. Oh my goodness. Yeah, blockchain. So probably a 5-year-old cannot understand this concept because he lacks the knowledge necessary to understand this concept. I'm not sure about that. It's just an example. So if you are talking with someone who does not have the same amount of knowledge as you, so you cannot explain something because of that gap, knowledge gap or something like that. So I'm just enough, but okay.
Okay, Diana, in this video, you have the right idea, but in this video, he talked about knowledge gap in a specific context. He said in the old days, only the monks and the gurus on the mountain had clay stones with written knowledge on it. So the common people only knew what the monks and the people that had this small amount of written documentation told them.
Earlier, you mean, in the history, okay.
Yeah, in old history. Once the printing press was discovered, now this knowledge of these few could suddenly be distributed to everyone. So now there were no more knowledge gurus or oracles who were the only ones that had the knowledge, because the printing press, paper copies made the knowledge available everywhere. So he talks about the printing press solving the knowledge gap by taking knowledge from the hands of a few and putting it into the hands of the many.
Yeah, so as teacher Lee said, it was in a special context. It wasn't like he spoke about problems that society faced. So it was a huge problem that which were solved for now, and it's led us to problems that we have today, like that. So it was a context about that.
Okay, so now we have the information, like the knowledge is available for everyone.
Yeah.
Yeah. Okay, so that's why the knowledge gap is solved.
It's solved not now. It's solved by first, printing machinery. When we don't need to write books like monks in churches. When we when we can print it and spread it to schools. So knowledge gap is over, right?
Okay.
So what is the power gap? Vasans, do you understand it?
Yes. Power gap was filled, or it was solved by the machines, the automations. So I don't really understand what was the problem, but the power gap was solved by the machines.
Yeah, no. So problem was about physical power of human, right? As far as we use only horses and human, we are kind of restricted in our efforts, right? We cannot we cannot solve too massive work or something like this. So after machinery, after simple mechanics, it's done. We can build huge buildings or something like this. So it's done for now. So the next one is a distance gap, and Diana talked about that already. But it's not exactly about physical body, because now we have choices. Sure. Now we have opportunities, right? So 2 centuries ago, you have to travel for 2 months. Maybe
yes, to speak with teacher Lee, like to travel for all your life, just to exchange a comment or two.
Yeah, and even if you send mail, you have to wait for months for answer. Yeah, so it was a distance gap. Now it's solved. We speak from different continents. We don't have this problem, so it's solved. But so it was like example of serious problems that faced humankind, but now this problem is solved. So next problem, according to the speaker, it's a problem of trust, right? So teacher Lee, can you explain it clearly? What is that? If you can. I can try, but
what he talked about basically was Diana, you're familiar with an accounting, bookkeeping. You keep a ledger of all the transactions So you know what was bought, what was sold, when it was done, how much. Electronically, we're doing that now, but the problem is people can go in there electronically and delete records and put in a fake record, and your chain of transactions is not trustworthy in the current environment with our technology. So people can tamper with records and embezzle electronically and do things like that. So the idea of BitChain is it's a new way of bookkeeping by electronic ledger, where when you enter a transaction, the next transaction is a hashtag of the two transactions.
Yeah, I can show slides. I prepared some slides about this, about blockchain, so it's easy to understand. But speaking of this problem, of this trust gap, so what is the problem? Problem is that there are many problems, but a few of them, like first one, it's centralized. You know, you delegate this knowledge to someone. So, for instance, let's speak about property. You know, who owns this property? There is some list, right, about owners and property, and this list is kept, right, by one authority center, like belong to government or something. So there is one point where this knowledge exists, and it can be changed at this point, and we have no chances to check or to influence on this. Right, so we cannot be sure that, for instance, if you delegate this keeping these records to government, we cannot be sure that government does not make fake records or does not change records or something else. We just don't have this mechanism. So we have to trust our government. For instance, in this particular example, maybe you have to trust your bank if you delegate your bank account to your bank, and it's always gap of trust. You have to have this trust level, because you don't have another opportunities to check that it's right. It's never was like changed. Vasant, please.
Yes, he mentioned that trust is the fundamental currency in economics. So, for example, in our real life, when we buy something online, for an example, if I buy something online, I can only buy the things that I can afford, like a $200 or $300. But I would not order anything that would cost my entire month's salary, because that's where the trust part comes. When it's expensive, I cannot trust anybody, because if something wrong happens, then I have to go through some difficulties, a chain of processes. So that cost me a lot of time and money. And in offline purchases, for an example, some shops offer you this, that the shop owner has to trust the customer, because he has to pay the money every month by installment methods. So the trust comes everywhere. Trust is the basic thing. Even we invest the money, the trust is the main thing.
I see, yeah. And I just noticed that Faisal joined us. Hello, Faisal. Can you speak today?
Hello, guys.
Hello.
How are you?
Yeah, I'm referring to you, you know, because I think that you have a brilliant example of this trust gap. Because you shared it to me. I'm not sure that I can retell it to our group correctly, but I can try. Please correct me if I'm wrong. So it's the same example as I provided about owners of property. And because of history of Morocco, because it was a pretty complicated history, it was for instance, Tanger was an international town with many governments, like Spain, what else? French, maybe. I forgot. It was 3 countries, right? And
Yeah.
There were 3 centers of trust, you know, 3 centers of truth. What belongs whom? 3 different ledgers, 3 different like accounts. And now we have a 4 generation of this trust center. It's a Moroccan government, and they have to choose which is this apartment, whom is belong. And it's not easy task. Am I right, Faisal?
Yeah, I agree with you.
So and this situation is possible as a result of this centralized system, you know, because it's 3 different books with 3 different information, and we cannot combine it together. We cannot check. We cannot say who is more trustful than other. So it's just useless. That is a problem of our delegation, our trust delegation, maybe something like this. I don't know if I'm explaining correct. Any questions at this moment? We are trying to we are trying to define the goal. Why we need some solution in general about that. So, do you think we reach this point? Do you think we ready to show the solution? Okay, let's think so. So the idea of blockchain in general, it's in 2 words, my opinion. It's using the special cryptographic methods. Using the special cryptographic methods, we have to make every record in our ledgers depend on previous history. So if we change anything in this document, in previous records, all the following records became invalid, and it's very easy to check. So we have to invent such mechanism. So we have to invent mechanisms that changing 1 number in the whole book will make the whole book incorrect, and we have to find a way to protect this, to make it very easy process. So we don't want to spend, you know, years just to check this. We have to check it in no time. You show me numbers, I see it's incorrect. Why? That's why. So it's a problem, and it's based on a cryptographic idea of hash. And I will try to share my screen because I made some slides first time in my life. Okay, I'm trying to screen share. Can you see it? No.
Black
screen. Okay. One second more. Again, problem with Hangout. Thank you, Hangout, for that. Trying again. Okay. It's black screen, right? Because I see black screen. Okay, nice.
If it's a Padlet, Ivan, we can just switch to another tab and look at the Padlet.
I can share the link, I think, but I wanted to show it. So okay, I'm copying. I copy link to our chat there. Okay. Please click on it, and you should see some presentation. Let me know if it works. Have no idea what's wrong with that screen share. Hello, Andrei. Can you speak with us? Do you hear us?
In the link, I can see the presentation in a different tab.
Okay, nice. Let me try again to share it because it definitely works.
Huh.
But not for screen sharing. Okay, one more try. Last one. Okay. Does it work now? No?
Yes.
You can see, right?
Yes.
Okay, because I cannot, but I'll try to explain. Yeah, really. So I see black screen, but if you can see it, it's nice.
Yeah. This is the hash screen we're looking at.
Okay. So let's start from that. So hash is a key point in all this blockchain thing. It's a key point for cryptographic, for everything. So what is the hash? What is hash? let's speak about this a little bit. So hash is a fixed length digit that calculated based on your data by some hashing functions. So you can see on the picture on the right side. So you have some random input. There is some messages like fox, the red fox jumps over the blue dogs, and so on. And they became to be just a number, just a fixed length, right? Fixed length byte string. So some numbers. And let me provide more examples. So examples. For now, I calculated a few very common hashes for now. MD5 and I don't know how to pronounce it. SHA-1. So it's a very famous for now, useful. MD5 kind of obsolete, but it's how it works. You put any string, any data, picture, I don't know, music, something else, and you get like 32 bytes of information. It's some magic. But not all these hashing functions are good. We have a few requirements for them. So what are requirements? First one, it must be fast. If you calculate it too long, it's not useful. We cannot easy check. Second one, it should be kind of random. We should not predict the result based on our data. It must be random. Third one, it must be one way. One way means you cannot restore the message by the hash. It's an important point I will show later. And the last one, it should be hard to find the collisions. So what is collisions? Let me show you. For instance, there is two pictures. Pictures just a message, just a set of bytes. These two pictures have the same MD5 hash. It's coincidence. It's you can see that pictures are pretty different, but they have the same hash. The good part of this that it's the only example that humankind found for now for collisions. So it's happens very rare. Usually, two different pictures, two different messages have different hash. It's very important for us. And one way. Okay, second. And when one way means that by given hash, for instance, I provided there one, we can predict what kind of message it was. There is no way to restore the message by hash. So it's always work from Y way, from data to hash. Okay, I pressed something correct.
So Ivan, the hash code is random. It's not an algorithm encryption.
It's an algorithm, but it should be C-random. It's what I mean. So it should looks like a random number. So it cannot be like predictable. But for one message, you always have the same hash value. It's predicted. So
okay.
So every time when you put the same message, you have the same hash.
So it's still key encryption, right? It's not some kind of key encryption, right?
Well,
so it can be encrypted and decrypted if you've got the right key.
But you cannot restore message by hash. Hash is kind of your fingerprint, something what you calculate based on your data, but it's not encryption at all. You cannot get message back.
Okay.
But so I'm sorry, I have a question. You just said that if you have the same message, right? The same message, you will have the same hash, right?
Right.
But in such a way, if we think logically, then there is a key, a kind of a key that you can solve, right? And understand how it's encrypted.
How it's calculated.
I understand what you're talking about, but this, this size of hash, it's 32 bytes. It's kind of too much for you. You can't write all the combination. It's probably more than we have atoms in university. So
Deanna,
it's.
Are you familiar with a checksum, Deanna? A checksum. Have you ever heard that term?
Teacher Lee, it's kind of the same. Checksum. It's about hash.
Similar, yeah. Okay.
Yeah, it's about hash. Yeah. So how we use this hash? For what? First of all, I provide only a few examples. First of all, first example is indexing something. You know, you have a you need to organize some library, some storage of some kind of object, and you want to answer immediately: do I have this object on library already or not? So you just calculate all these hashes, all these checksums, and when you have new object, you can fastly calculate hash and check it with your list. And you already know, do you have this object or not? Is it clear? Or not?
Yeah, it is clear.
Okay, okay. So again, I press it incorrect button. Next usage, it's kind of hiding information. For instance, Facebook or Google or other companies, they never store your password on their servers. So that password cannot be stolen because it doesn't exist on their servers. How they check this? They store hash of your password. So if your password, I don't know, 1, 2, 3, 4, 5, they have the same hash all the time. But by hash, you cannot restore your password. So it's kind of hiding information, kind of safe way to compare things. Is it okay? I'm sorry that I'm asking because I don't see your video, you know.
But Ivan,
yeah,
people are stealing data from Yahoo and other places, and they are getting our passwords.
Yeah, but it's.
I don't understand. This doesn't make sense. It's not hidden right now.
It's hidden, but some services we can call them bad services. They store passwords instead of hashes.
Okay,
And when they are broken, you know, passwords go out. Another way, sometimes passwords are stolen from your browser by some malware, by some bad program, not from server sites. Okay, another example, more complicated. We are ready to that. It's a kind of signing documents. Let's imagine the situation that Alice and Bob have some secret key, some password, some words that only those two people know. So Alice want to send message to Bob and verify that message wrote by her, not by anyone else. What is the simple way to do that? It's simple. We put a message, add secret password to that, and calculate hash. I provide example, right? Hash from hello Bob secret pass is something I wrote, 0xc and so on. So Bob on his side can check it easily because he knows secret password, he knows message, he can see message, he calculates the hash, and if he sees that the hash is the same, right, he knows that it's exactly original message. It cannot be changed. Let's talk about this a little bit more. For instance, some new guy, John, wants to change message. Instead, hello, Bob, write goodbye, Bob. He cannot calculate right hash for that because he don't know secret password. Is it clear or already not? Okay. It was important usage for our blockchain. Okay, and what else?
Ivan,
yeah, please.
Yeah, I have a question. So you are saying that, for an example, if I log in, they only matches the hash, so they don't matches the password. So if I type in my password, so the server checks with my hash key with their server's hash key. So they don't directly check the passwords, right?
Right.
They only. So, and how about the messages? So you're saying the message is converted to hash key. How the message is delivered to the right person with the same message? How do you calculate the hash from the hash to the message.
Yes, it's you mean how we guarantee, how we make sure that message not changed? This one or not? Or you speaking about like right correspondent or right address?
No, yeah, even the correct person receives the message. How does he know the correct message, the context of the message? How do you convert it again?
Because
the hash to,
because you know, two conversations, two conversation site. In our example, it's Alice and Bob. They know common secret. They know common secret, and they check hash by adding this common secret to the message. So they hashes match. But if you are someone from who don't know the secret path, you cannot change this message because your hash will be different.
Yes, now I understand. Like the end-to-end, end-to-end.
Right, end-to-end mean exactly the same thing. End-to-end means that two devices or two users or two clients have some shared secret, and it's a kind of warranty that they will have unchanged messages.
One way it might be easier to think about it is think about a communication as having two padlocks, two locks on it, okay? The originator has one key. We call it the private key. So when he puts his key in there and turns it, he encrypts the message with his private key. So one of the locks has been actuated, if you will. So when I send that message to you, I also send you a copy of my public key that I can give to everybody. So when I give you a message with my public key, your computer stores my public key on your computer. And it takes my message to you and it uses that public key to unlock the lock, the second lock. If my private key is in the first lock, then my public key that you can use will show my message. When you write me a message, your software uses my public key in the lock for that message. When you send it to me, only my private key can fit that lock to decode that message where I can see it. So that's kind of how it works. It's like a two-key process.
Yeah.
One, only the originator possesses. The public key he can give to many people.
Yeah, what you are talking about, it's called async cryptography because it's asymmetric. We have own sets of keys, public and private. We never shared it, but it's based on hashing, of course. Everything in cryptography based on hashing, but it's kind of another algorithm. It's kind of because
it's just an idea. Okay.
Yeah, it's the idea of asymmetric cryptography. Actually, we don't need asymmetric for blockchain.
Okay.
Just hashes is enough. So I don't expect that it's totally clear now, but at least something. So let's speak about blockchain. Let's imagine that Alice and Bob don't have a bank, don't have some trust center about money. Instead of that, they have some ledger, paper book where they write all the transaction. And both of them wants that it will be unchangeable. It was make it untamperable. Is it a word actually? Untamperable.
Yeah.
Okay. So no one can change it and hide the fact of change. How to do that? Let's see. I provide example of records, right? Like date, transaction, amount, and hash key, and hash based on this data. So the idea of blockchain is that we add previous hash value to data on the next row, on the next record. So next hash related, how to say it, based on previous hash. So this way, let's imagine we change something. I changed one amount on the record 2. I changed the amount of money, and as you can see, hashes changed, and we can see exactly on which record hashes are changed, and we can knew immediately because hashing procedure is fast. It's easy to do. We can knew immediately which record is incorrect. Is it clear or not? So in this way, we don't need someone else, some like bank manager or some like government who will guarantee that all that unchanged. But
okay, how do you know that the second set of hashes are changed? You just see the hash, just okay. You see the first one, which is the first one, so it doesn't matter. So then I see, okay, I'm looking at the bottom of your slide, with the tempered. With the changed information. So I see the other hash. And what does it mean? It does not include the previous one, or how do you know that it is tempered? What I just see the random.
Yeah, excellent question. Excellent question. Because every time when Bob and Alice put a new record in this ledger, both of them get the last hash, from the bottom to their wallet. And if it changed, it means somewhere in the history something changed. Because every next hash depends on previous hash. If something changed, you see that the checksum, right? We can call it no hash, incorrect, and it means that somewhere in the history something changed. So it's
so that means that it does not include the previous one, right? So and if some hash does not include the previous one that you received before, that means that it is changed. Okay, it has been changed.
So let me kind of explain it, Donnie. If you look at the screen, let's say that the very bottom transaction, $25, you just did. So what the system does is it looks at the above the top chain, and it compares all those hashtags to the chain that you're looking at. And if you go back from your hashtag to the top hashtag, if they're all the same, then your transaction chain is verified. But if we look at your series of hashtags and compare those to the public storage hashtag chain, you'll see that some of the numbers are different now. So at the point where they become different means the records were tampered with in what you're looking at.
Yeah, it's correct. And actually, you need just only one hash, the last one. It's a blockchain because it's a chain of hashes. Block, it's another word for hash, So blockchain is actually it's a chain of these hashes, and the last one, the next one, depend on the data and the previous hash. So all what you need to store is the last hash. It's incorrect. Okay, something wrong. So it's what we see on this slide. It's already blockchain. It's already works, but there is a few improvements that can be made. So, but at this point, is it clear? Can we go to more complicated example?
As far as I understand, so if you want to check the hierarchy, the chain, so the hash key changes when somebody changes the. So
right.
If you suspect something wrong, so you can go back to the layer, and where the hashtag remains unchanged, that is okay. So since from the change happens, then that's where the problem occurred.
So if you have all sets of hashes, if you have it recorded somewhere in another place, you can restore, you can find the place where a mistake was done. Or mistake or deliberate change or something like this. But usually blockchain doesn't solve this problem. The blockchain is already decentralized. It means that Bob has own ledgers, Alice has own ledger, someone else. It's free to copy. You can, you can distribute this as much as you want. But how to check is your copy correct or not? You can compare it just by one number. At this one number, it's called like last stamp or something. So when people put a new record, they share this last record, the last hash.
Mhm.
Okay, let's so it's already it works, but there is one problem. Just imagine that Alice and 3 more men or human, right, try to rewrite the whole history. Try to rewrite the whole history, and it's pretty simple because calculating rewrite the whole history and then pretend that it's a real history. Then pretend that you write your hash just incorrect. You know, it's a real history. How to protect from that? And there is a trick for that. And trick is this way. You know, please look at column number 3. There is some random. Random data like Z, K, F, H, 3. I added this data here, especially that hash looked, you know, pretty. That hash started to have these zeros at the end. And found in this way, it's additional job. I have to put in my ledger, in my blockchain, not only the data and date, but I have to put a special string adding to this data to make this hashes looks similar way, like with leading zeros. It's not easy to do. It's a really hard task to find this additional string, because as we know, hash is one-way thing. So to find this string, I have to make a brute force. What is brute force? I just checking a lot of random strings, maybe thousands, maybe millions of that, and calculating hash for every iteration and see if hash is special or not. So it's special guy does it. We call it miner, and miner is the one who signed your transaction by this way. He has special like devices or a lot of computers that can calculate in pretty fast time this additional string to make your hash looks good. Is it clear or not?
Why do we care if our hash looks pretty?
Yeah, it's an excellent question. We don't actually we don't care about this prettiness, but you know, at this point, just imagine that someone there is a two important facts. First fact, it's very hard to find this string. It can take, you know, years for usual computer, like 10 years maybe, because you have to brute force a lot of numbers. So it's just additional conditional that makes this works, putting new records very hard. And imagine that you want to change some history. You need to generate like 10 or maybe 100 records. And you have to brute force strings for 100 records. And if you don't do this, if your hashes looks like from previous example, you know, without zeros, that everyone is looking without even computer. It's clear that it's fake. Not clear yet? So it's not especially, it must not be especially leading zeros. It must be any condition. But it's some special conditions for hashes, and it makes this process of falsification even harder, because you need special devices for that. And these miners receive some percent from every transaction, some revenue from that, but all cryptocurrency now decided that it's worth it. So it's yes, I try to write it there.
So a miner is a legitimate job that we pay people to do something for us?
For instance, if you do transaction in cryptocurrency and your transaction is like $10, for instance, and you have to put this record on your book. When you put it, there is a special like miners pool. They provide you string, but take like 1% of your transaction. So it's like what bank do for you when bank do some transactions. But but it's different. So it's all about my presentation. I hope that something more is more clear now than before, and we can discuss it more. Please.
I have a question, Ivan. So you said adding some zeros at the end of the string, it is hard to find that. So in my opinion, how about, let's say it's just a 10-digit of numbers and you are adding five numbers and 5 zeros at the end. So it is pretty easy to just work for the first 5 digits and just adding the 5 zeros at the end. So when they calculated the string. So
I see. I think that I maybe explain it better. You know, we don't add zeros to our hash. We add some random string, to our message, to make hash look so good. You know, with leading zeros.
Okay.
And let me show you another trick. I know that the best way to understand something it's try to calculate this. So I'm share some service like generator. Sorry. Okay, I will share it later on the chat. You know, some special service. You put any data to that and you receive hash immediately. And it's like a homework, you know. Try to put a string to get 2 zeros at the end. It's very hard to find such strings. So you will try maybe for million different strings to find this one. You know, so it's not easy task. And for conman who trying to modify the whole book with 1,000 records, you need to spend, you know, like years of job for every records to find the string. So it's addition. Please.
Are you saying the miner is the one that generates our hash code and we have to pay him to do that?
Hash code is pretty simple to generate. You know, every computer can calculate hash code because it's fast process. But okay, let me show you.
So why do I need the miner is my question.
To find this additional string to make your hash better. For instance, let me show. For instance, we have string. I will write to the chat. For instance, AA11. We have this string. Hash from this string is something like it's not real hash. I'm just providing it like this. Okay, I ask miner, please give me some string which is 4 letters long, something like AABB. In this way, that hash from the result string looks like this way. So the task of finding this additional string ABB in our case, it's very complicated task because you have to check all the strings, you know, in the universe to put that in this equation and get the result.
So you're saying it increases the security?
Yeah, because
but it's not necessary, right? If I don't want to do it, do I have to do it?
At this point, yes, because it's now a standard for every cryptocurrency. So people decided that it's increase security in a very good way. Gerard, please.
I read that miners are very important with Bitcoin transactions.
Right.
And you have to spend a lot of energy of doing that because many computers are involved.
Right.
Right. That.
Right. It's what we're talking about just now. Because why miners are important for making transaction? Because without miner, you just cannot put this transaction in blockchain because you don't have the string, you know, to put the your hash does not satisfy all the requirements. And before it will be done, you cannot put the record into the blockchain. So you have to pay some miner for that. But miner, it's not like, you know, one guy. You can be one. You can be miner if you want to. You just buy a special computer, connect it to the internet, and you already a miner. It's like an auction at the same time. You provide some price. I will solve your hash for $1. Okay, another guy provides another price. I will solve your hash for $2, and it's already automated, fully automated. So you pay some fee to put your record to this blockchain, and this fee distributed by miner pools. So it's the way to. So these collective miners are represent for us like bank, or something like this. So we pay them. We don't pay any bank. But what is the benefits? Because anyone can be miner. You don't need anything special for that. You need a lot of electricity, good computer with special video card, because video cards are good in finding hash, but it's irrelevant to blockchain. It's just a coincidence. So this way, so miners are like workers for our blockchain.
So you're saying the miner creates the record that goes into the blockchain?
Yes, they format in special way. They solve this equation, format these records in special way. You pay the fee, and record go to the blockchain, to this chain, and then it's distributed to every other computers and markets and special pools, and now it's proved.
So whoever controls these miners is going to make a
how to trust those miners now.
Yeah.
I don't trust those miners.
Why not? Why not? Because it's a what they can. Okay, let's think about this. What they can do wrong?
Well, we don't know because we don't see the data. We have no idea what they're doing.
You put your data. They don't put nothing into blockchain without you. You just say, for instance, I tell if Gerard, our miner, I say I want to put record like $15 to this account. Give me a hash for this. Give me a special additional string to make my hash correct. I will pay you $1. That's all. And when I receive this string from Gerard, I checking that everything is good. It's still $15, not more. It's still to this account. I check all the things, so my data is uncorrupted, and then I put it into blockchain because now I have this.
So you put this additional thing that this miner provides you. Okay.
So you not delegate any rights of your wallet to miner. You just pay him for work to find this additional string.
Additional, okay. Mm-hmm.
So I'm paying for every single electronic transaction I do now.
You do it. You do it already
to someone.
Yes. Every transaction you pay, but it's a really small amount of money. So when I said it's 1%, it's not correct. It's a lot of zeros between this person, like 0.000 and something at the end.
Right.
Okay, but you don't have to pay bank. You don't have to pay anyone. And sometimes, sometimes it's very interesting. As I said, it's auction. It's miners provide their prices, and you can provide the price. You can say this transaction is very important for me. I need to make it in no time, so I pay not 1%. I pay $100 for that. And miner pools will combine and solve it fast for you. Because sometimes if you pay a little fee, sometimes transaction can be solved for a day. You can wait for a day before this thing will be found.
Right.
So it's a kind of a way to make a decentralized and out balanced system. It's all balanced by money without any human.
I don't see how that software is unbelievable. Jesus. Okay.
Okay, any questions? Sergey, you quiet. Do you understand anything? Probably we lost him. Gerard, please.
Is there a way to hack that?
As far as we know, just now there is no ways. There was one successful attack in the past. It was at the beginning of crypto era when blockchain just was invented. The first generation of cryptocurrency was attacked successfully. So they found a hole, and they have to close the hole and restart the whole system. And they do that. They did that, but it was like very long time ago. For recent, there are no recent case of anything hackable.
And what about this problem of Intel processors? The meltdown problem.
Yeah. But
does it affect to that?
No, successful. Happily, no. It's about other things. It's about, you know, I don't know. Should I say it for record? But it's about not very successful backdoor from, you know, from someone. So it's just a mistake in processor that can be, and it existed for decades. So it's very long way. Yes, and it's not related, not quantum computer, not this recent backdoors, not related to blockchain. All what we have to understand blockchain, it's hash. That's all. Any questions?
I guess one more. The guy in the TED Talk kind of described a hash authority for each industry, like steel or shipping or medical. Who is or where is the central authority for all of these blockchains? Are they centralized, or are they, you know, who's the authority on maintaining the data, I guess?
There is no authority. It's just it's decentralized totally. So you can buy computer connected to the network, and you now partially at center of authority. And people, you need to do that. It's not altruism. You need to do that if you want to get fee for this data from the transactions.
So the ledger, if you will, is not in a single place.
Right.
Copies of it are just passed around and compared.
It's almost impossible to put a new record without copying the whole previous story. So for now, the whole blockchain, for instance, of Bitcoin, it's very popular cryptocurrency. It's now like 5 gigabytes or something like this. So the whole history, yes. But for modern computers, it's not a problem. And you don't have to have it in your wallet. In your wallet, you have only last hash, you know. But special centers who get fee for that, they store all the data. Vasant, please.
Yes. So now we learned about the blockchain. So my question is, how is it connected to the Bitcoins?
Right.
How they process it, how they use it.
And as you can see, our time is almost over. That's why I I decided to split it into parts. So blockchain today and cryptocurrency next day. So now when we understand clearly how blockchain works, I will show a way how to build a money and transactions and how to buy things by using blockchain. Wow. Sergey, last chance to ask something.
It's difficult for me, and I have a lot of questions, but I should create the questions for you.
Okay, don't worry. You can write any questions to chat. You know, let's call it a week of cryptocurrency. Any questions will be answered. And I shared a link to the presentation. And please, if you we can improve it together just by your request. So I think that's all for today. Thank you very much for coming.
Thank you very much, Ivan.
Thank you very much.
Bye.
Bye.
Bye-bye.